And next up is harmonic progression. So if we say harmonic progression, that's basically the reciprocal of the arithmetic progression. So for example, under arithmetic progression, okay, we have the terms, let's say a sub 1, a sub 2, a sub 3 up to the n term a sub n. How do we write the terms equivalent to the harmonic progressions? So we have the under harmonic progression, all we have to do is take the reciprocals of the terms. So we have this is the same as 1 over a sub 1, 1 over a sub 2, 1 over a sub 3 up to 1 over the n term, 1 over a sub n. So if we have the terms of the harmonic progression as the reciprocal of the terms of the arithmetic progression, how do we compute for the n term? So let's say n term of harmonic progression. So basically what we have to do, since we don't have a specific formula for the n term of a harmonic progression, all we have to do is first, convert to arithmetic progression. So we are to convert all the terms to arithmetic progression, then we can use the equations under arithmetic progression. So for the computation of the n term, this is a sub n, the first term plus the number of terms minus 1 multiplied by the common difference. So convert to arithmetic progression, use the equation under arithmetic progression. So next is we are to take the reciprocal. So for example, we are able to compute for the n term of the arithmetic progression. To have it under harmonic progression, all we have to do is, so harmonic progression, all we have to do is take the reciprocal. This is a 1 over the a sub n. That will be the n term of the harmonic progression. So let's have an example. So for example, we have the terms 1 half, 1 over 7, 1 over 12. So first, we are to convert the terms into arithmetic progression, or basically we are to take the reciprocal, then check if they are really under arithmetic progression. So we are to convert under arithmetic progression. So what are the terms? Okay, or before that, we assume them to be under harmonic progression. So this is 1 half, 1 over 7, 1 over 12. We are to convert the terms to arithmetic progression. So we have 2, 7, and 12. So let us check if we have a common difference for an arithmetic progression. So we have this as 7 minus 7 minus 2 is equal to 5, and we have 12 minus 7 is also equal to 5. So therefore, we have a common difference. This is an arithmetic progression. So for example, we are required to compute for the 30th term. So example, we are required to compute for the 30th term of the harmonic progression. So what will be our first term under arithmetic progression? Our first term is 2. The number of terms required is, we have 30. So how to compute for the n term under arithmetic progression? We have the equation a sub n is equal to the first term plus the number of terms minus 1 multiplied by the common difference. So we are looking for the 30th term. This is a sub 30 is equal to a sub 1. Our first term under arithmetic progression is 2 plus this is 30 minus 1. Our common difference is, we have 5. So we are having the 30th term under arithmetic progression. So it's the same as 2 plus 30 minus 1 divided by 5. So the 30th term is equal to 147. So that is the 30th term for the arithmetic progression. Okay, so we have under the arithmetic progression, what is our a sub 30? We have 147. So again, if we say harmonic progression, that is the reciprocal of the arithmetic progression. So therefore, our a sub 30 under harmonic progression is basically 1 over the 30th term of the arithmetic progression is 147, and this will be our answer. So this is our first example. Okay, let's have another example for harmonic progression. For example, in a harmonic progression, compute the 10th term if we have the third term is equal to 1 over 22, the fifth term is equal to 1 over 32. So how do we compute for the 10th term? So first, we are to convert the terms into arithmetic progression. So again, under harmonic progression, our third term is equal to 1 over 22. Our fifth term is equal to 1 over 32. So if we are to convert these terms into arithmetic progression, the third term is, the reciprocal of this term is 22. And our fifth term, the reciprocal of this term is, we have 32. So since we have now the terms under arithmetic progression, we analyze them as the terms of an arithmetic progression. So we can use the equation a sub n equal to a sub 1 plus the number of terms minus 1 times the common difference. So we have n is equal to 3, that's our third term. We have 22 is equal to the unknown first term plus we have 3 minus 1 multiplied by the common difference. We have 22 is equal to the first term plus twice the common difference. Let this be our equation number 1. So we have n is equal to 5, that is for the fifth term. Okay, we have this is 32, our first term is unknown, plus we have 5 minus 1 multiplied by the common difference. We have this is 32 equal to the first term plus 4 times the common difference. Let this be our equation number 2. So let's have by elimination, let us determine the value of the first term and the common difference. So from equation 1, 22 is equal to a1 plus 2d. That's equation number 1. Then we have equation number 2. This is 32 is equal to the first term plus 4 times the common difference. So let's have equation number 1 minus equation number 2. So 22 minus 32 is equal to negative 10. A1 minus A1 is 0. Equal to negative 2d minus 4d is 2d. So we're having negative 10 is equal to negative 2. Obviously, our common difference is negative 10 divided by negative 2 is positive 5. So since we have now the common difference, we may use equation number 1 to determine the first term. So this is 22 minus our first term, unknown, plus twice our common difference is 5. So therefore, our first term, a sub 1, that is 22 minus 10, we have 12. That will be our first term. We are looking for the 10th term. Okay, again, we are using this one. That is a sub 10 equal to, first term is 12 plus the number of terms, since we have 10th term, that is 10 minus 1, common difference is 5. So we have the 10th term is now equal to, that is 12 plus 45. We have 57. So we have the concept for arithmetic progression. We have the 10th term as 57. For harmonic progression is equal to 1 over the arithmetic progression. The 10th term of the harmonic progression is basically 1 over 57. And this will be our answer. the 10th term of the harmonic progression. So let us discuss how to determine the sum of n terms of a harmonic progression. So basically, if we have to compute for the sum, that is the same as 1 over the first term plus 1 over the second term plus 1 over the third term, and so on. So there's no specific formula for the computation of the sum of the terms of a harmonic progressions. So we don't have a formula for this one. So the most convenient way to compute for the sum is we may use our calculator if we have the sigma function. So if we have a calculator with a sigma function, so let us determine the sum using our calculator. So the sum is basically equal to the summation from x equal to, let's say, from our first term up to n. Then we are to input the reciprocal of the formula for the n term of an arithmetic progression. It's the 1 over a sub n. So that's the same as the summation is the same as we have the summation from x. This is from x equal to 1, the first term, up to the n term of 1 over, what is the a sub n for arithmetic progression? That is the first term plus, we have n minus 1 multiplied by the common difference. So we cannot apply the concept of arithmetic progression to compute for the summation. Okay, we cannot use the summation formula for arithmetic progression. So for example, we have the terms, let's say 1/2, the 1 over 7, and the 1 over 12. If we have to compute for the sum, what is the common difference first? The common difference is 7 minus 2 is equal to 5. We have 12 minus 7 is also equal to 5. So we need the common difference. So we have the summation is equal to, you have to input the sigma function of your calculator. That is from x is equal to 1, 6. We have the number of terms is equal to 3. We have 3 terms. So this is up to 3. We are to input 1 over, what is our first term? We need the first term, a sub 1. So that is 2 plus, in our calculator, we don't have the n. We are using x. That is x minus 1 multiplied by the common difference, which is 5. Then we can have the summation. So I'll be using a Canon calculator. This is So there are several calculators having the sigma function, the summation function, but this calculator is allowed by PRC for civil engineering board exam. So if you are to input that sigma, that is function number 2, so that is from 1 to 3, then that is 1 over, the first term is 2 for arithmetic progression. Then plus, we don't have n for the calculator, we are using x. So it's alpha x minus 1 multiplied by the common difference, which is 5. So exactly this is the terms in our calculator, then press equal. So we'll be having a value of 61 over 84. So if you are to do it manually, just for checking, so this is the same as 1/2 plus 1 over 7 plus 1 over 12. So if I do it manually using the calculator, 1 over 2 plus 1 over 7 plus 1 over 12. So we have that as, we have 61 over 84. So obviously, this is very applicable if we have many terms, but if we have only 3 terms, you can do it manually. But the advantage of this sigma function of the calculator, if we have, for example, 50 terms, 70 terms, 100 terms, and so on. So this is the most convenient so far up to present, the most convenient procedure to compute for the sum of the terms of a harmonic progression. Okay, so let us discuss the means per progression. For example, we have the arithmetic mean, geometric mean, and the harmonic mean. For example, we have the terms, first term is equal to x, and our second term, let's say this is y. If we are to compute for the arithmetic mean, if you say arithmetic mean, basically that is averaging. We average x plus y, so we have 2 terms, so divided by 2. So averaging for arithmetic mean. So how about for the geometric mean? What is the geometric mean of the first term and the second term? The geometric mean of the first term and the second term, we have a sub 1, a sub 2. Since we have 2 terms, this is raised to 1 over 2. Okay, so what about if we have multiple terms? For example, we have 5 terms. So generally, we have a sub 1, a sub 2, up to a sub n. Okay, the product of the terms. We have to compute for the product, then raise it to 1 over n. Okay, so that is for the geometric mean. But since we have only 2 terms, the geometric mean of x and y, so this is x and y, we have only 2 terms, so this is raised to 1/2. So we will be having the equivalent of geometric mean squared is equal to the product of the 2 terms, x and y. So by squaring both sides. So again, arithmetic mean is averaging, geometric mean is the nth root of the product of the terms. If you have 2 terms, that is the same as the square root of the 2 terms. Or geometric mean squared is the product of the 2 terms. So how about harmonic mean? So harmonic mean, to compute for the harmonic mean, so most of the time, common mistakes or common wrong assumption of most students. So if we have x and y, you are to take the reciprocal of x and y, then you are to average. This is the common mistake for the harmonic mean. But again, so harmonic progression is the reciprocal of the arithmetic progression. So we are to take the reciprocal of this term. So we are to take it as, we have the equivalent of the harmonic mean as 2 divided by the reciprocal of x plus the reciprocal of y. This is our harmonic mean of this 2 terms. So if we are to simplify, our harmonic mean is now equal to, this is 2 all over, we have a common denominator of x and y plus x. I will simplify harmonic mean is now equal to 2xy divided by, we are just to rearrange x plus y. Now if we are to observe this portion, what is the equivalent of the arithmetic mean? The equivalent of the arithmetic mean is x plus y divided by 2. What if we take the reciprocal of the arithmetic mean? What is the equivalent of 1 over the arithmetic mean? Is the same as, we are just to take the reciprocal. This is 2 divided by x plus y. So that is, if we are to expand the equivalent of the harmonic mean, separate this term, that is the same as 2 divided by x plus y. We have this 2 divided by x plus y multiplied by, and this is multiplied by x times y. So we have now the equivalent of the harmonic mean as, what is the equivalent of 2 over x plus y? 2 over x plus y is 1 over the arithmetic mean. That is the reciprocal of the arithmetic mean. What is the equivalent of xy? Xy is equal to the square of the geometric mean. So this is, we have the geometric mean squared. So we'll be having the equivalent of the harmonic mean as the geometric mean squared divided by your arithmetic mean. Okay, so the relation between the relation of the three means, if you have two terms, so the harmonic mean is equal to the square of the geometric mean divided by the arithmetic mean. So example, we have the geometric mean of two numbers is equal to 18 and the arithmetic mean is equal to 4. Compute the harmonic mean. So we have the harmonic mean is equal to the geometric mean squared divided by your arithmetic mean. So we have it. This is 18 squared divided by 4. As we have that as 18 squared is 324 divided by 4 is equal to 18 squared divided by 4 is equal to 81. So we have a harmonic mean of 81. And it is for harmonic mean.